Surveying or land surveying is the technique, profession, and science of determining the terrestrial or three-dimensional position of points and the distances and angles between them. A land surveying professional is called a land surveyor. These points are usually on the surface of the Earth, and they are often used to establish land maps and boundaries for ownership. Locations like building corners or the surface location of subsurface features, or other purposes required by government or civil law, such as property sales. Surveyors work with elements of geometry, trigonometry, regression analysis, physics, engineering, metrology, programming languages and the law. They use equipment like total stations, robotic total stations, GPS receivers, retroreflectors, 3D scanners, radios, handheld tablets, digital levels, drones, GIS and surveying software. Surveying has been an element in the development of the human environment since the beginning of recorded history. The planning and execution of most forms of construction require it. It is also used in transport, communications, mapping, and the definition of legal boundaries for land ownership. It is an important tool for research in many other scientific disciplines. Acsm Definitions. The American Congress on Surveying and Mapping defines surveying as the science and art of making all essential measurements to determine the relative position of points or physical and cultural details above, on, or beneath the surface of the Earth, and to depict them in a usable form, or to establish the position of points or details. Also per Acsm, the type of surveying known as land surveying is the detailed study or inspection, as by gathering information through observations, measurements in the field, questionnaires, or research of legal instruments, and data analysis in the support of planning, designing, and establishing of property boundaries. It involves the re-establishment of cadastral surveys and land boundaries based on documents of record and historical evidence, as well as certifying surveys of subdivision plats or maps, registered land surveys, judicial surveys, and space delineation. Land surveying can include associated services such as mapping and related data accumulation, construction layout surveys, precision measurements of length, angle, elevation, area, and volume, as well as horizontal and vertical control surveys, and the analysis and utilization of land survey data. History. Ancient surveying. Basic surveillance has occurred since humans built the first large structures. The prehistoric monument at Stonehenge was set out by prehistoric surveyors using peg and rope geometry. In ancient Egypt, a rope stretcher would use simple geometry to re-establish boundaries after the annual floods of the Nile River. The almost perfect squareness and north-south orientation of the Great Pyramid of Giza, built c. 2700 BC, affirm the Egyptians' command of surveying. The Gromer instrument originated in Mesopotamia. The mathematician Liu Hui described ways of measuring distant objects in his work Hai Dao Suanjing, or the Sea Island Mathematical Manual, published in 263 AD. The Romans recognized land surveyors as a profession. They established the basic measurements under which the Roman Empire was divided, such as a tax register of conquered lands. Roman surveyors were known as grammatici. In medieval Europe, beating the bounds maintained the boundaries of a village or parish. This was the practice of gathering a group of residents and walking around the parish or village to establish a communal memory of the boundaries. Young boys were included to ensure the memory lasted as long as possible. In England, William the Conqueror commissioned the Doomsday Book in 1086. It recorded the names of all the landowners, the area of land they owned, the quality of the land, and specific information of the area's content and inhabitants. It did not include maps showing exact locations. Modern surveying Abel Fowlon described a plane table in 1551, but it is thought that the instrument was in use earlier, as his description is of a developed instrument. Gunter's chain was introduced in 1620 by English mathematician Edmund Gunter. It enabled plots of land to be accurately surveyed and plotted for legal and commercial purposes. Leonard Diggers described a theodolite that measured horizontal angles in his book A Geometric Practice named Pantometria. Joshua Habermel created a theodolite with a compass and tripod in 1576. Jonathan Sisson was the first to incorporate a telescope on a theodolite in 1725. In the 18th century, modern techniques and instruments for surveying began to be used. Jesse Ramsden introduced the first precision theodolite in 1787. It was an instrument for measuring angles in the horizontal and vertical planes. He created his great theodolite using an accurate dividing engine of his own design. Ramsden's theodolite represented a great step forward in the instrument's accuracy. William Gascoigne invented an instrument that used a telescope with an installed crosshair as a target device in 1640. James Watt developed an optical meter for the measuring of distance in 1771. It measured the parallactic angle from which the distance to a point could be deduced. Dutch mathematician Willebrord Snellius introduced the modern systematic use of triangulation. In 1615 he surveyed the distance from Alkmaar to Bergen op Zoom, approximately 70 miles. The survey was a chain of quadrangles containing 33 triangles in all. Snell showed how planar formulae could be corrected to allow for the curvature of the Earth. He also showed how to resection, or calculate, the position of a point inside a triangle using the angles cast between the vertices at the unknown point. These could be measured more accurately than bearings of the vertices, which depended on a compass. His work established the idea of surveying a primary network of control points, and locating subsidiary points inside the primary network later. Between 1733 and 1740, Jacques Cassini and his son C.E.Acute.Sar undertook the first triangulation of France. They included a resurveying of the meridian arc, leading to the publication in 1745 of the first map of France constructed on rigorous principles. By this time, triangulation methods were by then well established for local map-making. It was only towards the end of the 18th century that detailed triangulation network surveys mapped whole countries. In 1784, a team from General William Roy's Ordnance Survey of Great Britain began the principal triangulation of Britain. The first Ramsden theodolite was built for this survey. The survey was finally completed in 1853. The Great Trigonometric Survey of India began in 1801. The Indian survey had an enormous scientific impact. It was responsible for one of the first accurate measurements of a section of an arc of longitude, and for measurements of the geodesic anomaly. It named and mapped Mount Everest and the other Himalayan peaks. Surveying became a professional occupation in high demand at the turn of the 19th century with the onset of the Industrial Revolution. The profession developed more accurate instruments to aid its work. Industrial infrastructure projects used surveyors to lay out canals, roads and rail. In the U.S., the Land Ordinance of 1785 created the Public Land Survey System. It formed the basis for dividing the Western Territories into sections to allow the sale of land. The PLSS divided states into township grids, which were further divided into sections and fractions of sections. Napoleon Bonaparte founded continental Europe's first cadastre in 1808. This gathered data on the number of parcels of land, their value, land usage, and names. This system soon spread around Europe. Robert Taurons introduced the Taurons System in South Australia in 1858. Taurons intended to simplify land transactions and provide reliable titles via a centralized register of land. The Taurons system was adopted in several other nations of the English-speaking world. 20th century. At the beginning of the century, surveyors had improved the older chains and ropes, but still faced the problem of accurate measurement of long distances. Dr. Trevor Lloyd Wadley developed the teleurometer during the 1950s. It measures long distances using two microwave transmitter receivers. During the late 1950s, geodometer introduced electronic distance measurement equipment. EDM units use a multi-frequency phase shift of light waves to find a distance. These instruments save the need for days or weeks of chain measurement by measuring between points kilometers apart in one go. Advances in electronics allowed miniaturization of EDM. In the 1970s, the first instruments combining angle and distance measurement appeared, becoming known as total stations. Manufacturers added more equipment by degrees, bringing improvements in accuracy and speed of measurement. Major advances include tilt compensators, data recorders, and onboard calculation programs. The first satellite positioning system was the U.S. Navy Transit System. The first successful launch took place in 1960. The system's main purpose was to provide position information to Polaris missile submarines. Surveyors found they could use field receivers to determine the location of a point. Sparse satellite cover and large equipment made observations laborious and inaccurate. The main use was establishing benchmarks in remote locations. The U.S. Air Force launched the first prototype satellites of the Global Positioning System in 1978. GPS used a larger constellation of satellites and improved signal transmission to provide more accuracy. Early GPS observations required several hours of observations by a static receiver to reach survey accuracy requirements. Recent improvements to both satellites and receivers allow real-time kinematic surveying. Rtk surveys get high-accuracy measurements by using a fixed base station and a second roving antenna. The position of the roving antenna can be tracked. 21st century, the Theodolite, total station, and Rtk GPS survey remain the primary methods in use. Remote sensing and satellite imagery continue to improve and become cheaper, allowing more commonplace use. Prominent new technologies include three-dimensional scanning and use of LiDAR for topographical surveys. UAV technology along with photogrammetric image processing is also appearing. Surveying equipment. The main surveying instruments in use around the world are the Theodolite and steel band, the total station, the level and rod, and surveying GPS systems. Most instruments screw onto a tripod when in use. Tape measures are often used for measurement of smaller distances. 3D scanners and various forms of aerial imagery are also used. The Theodolite is an instrument for the measurement of angles. It uses two separate circles, protractors or aladaders, to measure angles in the horizontal and the vertical plane. A telescope mounted on trunnions is aligned vertically with the target object. The whole upper section rotates for horizontal alignment. The vertical circle measures the angle that the telescope makes against the vertical, known as the vertical angle. The horizontal circle uses an upper and lower plate. When beginning the survey, the surveyor points the instrument in a known direction, and clamps the lower plate in place. The instrument can then rotate to measure the bearing to other objects. If no bearing is known or direct angle measurement is wanted, the instrument can be set to 0 during the initial sight. It will then read the angle between the initial object, the theodolite itself, and the item that the telescope aligns with. The gyrotheodolite is a form of theodolite that uses a gyroscope to orient itself in the absence of reference marks. It is used in underground applications. The total station is a development of the theodolite with an electronic distance measurement device. A total station can be used for leveling when set to the horizontal plane. Since their introduction, total stations have shifted from optical mechanical to fully electronic devices. Modern top-of-the-line total stations no longer need a reflector or prism to return the light pulses used for distance measurements. They are fully robotic, and can even email point data to a remote computer and connect to satellite positioning systems, such as Global Positioning System. Real-time kinematic GPS systems have increased the speed of surveying. but they are still only horizontally accurate to about 20 mm and vertically to 30 to 40 mm. GPS surveying differs from other GPS users in the equipment and methods used. Static GPS uses two receivers placed in position for a considerable length of time. The long span of time lets the receiver compare measurements as the satellite's orbit. The changes as the satellite's orbit also provide the measurement network with well-conditioned geometry. This produces an accurate baseline that can be over 20 km long. Rtk surveying uses one static antenna and one roving antenna. The static antenna tracks changes in the satellite positions and atmospheric conditions. The surveyor uses the roving antenna to measure the points needed for the survey. The two antennas use a radio link that allows the static antenna to send corrections to the roving antenna. The roving antenna then applies those corrections to the GPS signals it is receiving to calculate its own position. Rtk surveying covers smaller distances than static methods. This is because divergent conditions further away from the base reduce accuracy. Surveying instruments have characteristics that make them suitable for certain uses. Theodolites and levels are often used by constructors rather than surveyors in first-world countries. The constructor can perform simple survey tasks using a relatively cheap instrument. Total stations are workhorses for many professional surveyors because they are versatile and reliable in all conditions. The productivity improvements from the GPS on large-scale surveys makes them popular for major infrastructure or data-gathering projects. One-person robotic-guided total stations allow surveyors to measure without extra workers to aim the telescope or record data. A fast but expensive way to measure large areas is with a helicopter, using a GPS to record the location of the helicopter and a laser scanner to measure the ground. To increase precision, surveyors place beacons on the ground apart. This method reaches precisions between 5 to 40 centimeters. Surveyors use ancillary equipment such as tripods and instrument stands, staves and beacons used for sighting purposes, PPE, vegetation clearing equipment, digging implements for finding survey markers buried over time, hammers for placements of markers in various surfaces and structures, and portable radios for communication over long lines of sight. Software and surveyors, construction professionals and civil engineers using total station, GPS and other collector data use land surveying software to increase efficiency, accuracy and productivity. Land surveying software is a staple of contemporary land surveying.